Solving a system of inequalities, in this case by graphing, because that's really the only way you can solve it, is just like solving a system of equations by graphing. The only difference is you have to shade and you look at where the regions that you've shaded intersect. So instead of looking specifically at where the lines intersect, like equations, we're going to look specifically at where the regions that are shaded intersect. You're going to graph these just like inequalities. Just going to have more than one of them. That's the only difference. So our first step every time is going to be to set our line as y equals mx plus b. And then we're going to graph the line, and then we're going to shade above or below for less than, greater than equal to, less than, that kind of thing. So again, no different. You just have more than one on a graph at a time. So we're going to move through this fairly quickly because it's something you've already seen. I just want you to see what more than one on a graph looks like. So my first line is x less than or equal to 4. So first thing I'm going to do is draw the line x equals 4. And it is equal to, so this is a solid line. So the line x equals 4 is a straight up and down line going through 4 on the x-axis. And that is less than, so I'm going to shade to the right or to the left. And if you're confused about which way to shade, pick the point 0, 0 right here and say, does that work? Is 0 less than 4? Yes. So I'm going to shade this side. So I'm just going to shade this side. All right. Doesn't have to be perfect. And now I'm looking at the next line, the line y greater than 2. So again, I rewrite this as y equals 2. The line y equals 2 is a horizontal line going through the point y equals 2. But this is dashed because it's not equal to. And then I look at greater than, so I'm actually shading above. So when I shade above, oh, that's really thin. Where is that? When I shade above here, you can see that the only part where these two graphs intersect is going to be the green. I'm not going to, normally I would shade over on this side also, but I'm not going to, just so you can see that the green region is where they intersect. So that green region bounded by these two lines right here, no, that's not the color one, by this line here and this line here, that is my solution area all the way up there. So that's what I'm concerned about. That is my solution area. And that's it. So let's do a couple more examples. All right, so this next one, I've got y less than or equal to 3x plus 2 and y greater than or equal to 1/2 x minus 6. So again, I'm going to rewrite these as y equals and then graph it. So y equals 3x plus 2. 2 is my intercept, and my slope is 3. So I'm going to go up 3 and over 1, up 3 and over 1, or down 3 and back 1. There's my line. This is equal to, so I'm actually drawing a solid line, and my line's not going to be perfect. Yours doesn't have to be either, as long as you can see what's going on. Okay, and my next equation, I'm going to solve that first, is going to be y equals 1/2 x minus 6. So 1/2 x minus 6, that means my intercept is negative 6, 1, 2, 3, 4, 5, 6. And my slope is 1/2, so I go up 1 over 2, up 1 over 2, or down 1 and back 2. So this is my slope here. So I'm going to, this is also equal to, so this is a solid line as well. All right, now I got to figure out where I need to shade. I'm going to continue this line down a little bit more so they cross. All right, so where do I shade? Well, let's shade this one in yellow. So we're looking at less than 3x plus 2, so that's under here. And then we're looking at greater than the other one. Let's shade that in blue. Greater than or equal to the other line, so that's up here. All right, so where the green is, that's where they intersect. And that keeps going on and on forever. That's your answer. So we're looking at where they intersect. The next problem is a little bit different because now we have 3 inequalities instead of 2. So this is actually going to determine a region, or in this case, a triangle, or it could be a quadrilateral. But it's going to be some type of polygon. Whenever you have more than two, you're going to be bounded by some type of polygon. So let's draw these lines really quickly. So this is the line y equals x. That's really easy. That's just a line that goes diagonally through the origin. It is equal to. And it is less than that. So we are less than that. So we're below. So we're just shading below that line. Okay, now our next line is y equals negative 2/3 x plus 6. Okay, so if we go to 6, that's our intercept. 1, 2, 3, 4, 5, 6. And it's negative 2/3. That means I'm going down 2 over 3, down 2 over 3, down 2 over 3, or up to back 3. And this is also equal to, so I can draw a solid line here as well. And this tells me I need to shade below that. So I'm going to shade below. So I'm shading below here. So below this line, shade that in. Okay, so far I'm dealing with this region here. And then my last line is going to be y equals 0. So the line y equals 0, well, that's the x-axis. So that's actually already drawn for me. That's right here, the x-axis. And I'm shading above this. So for this one, I'm going to use purple, and I'm going to shade above. But the actual only part that I'm going to have to shade is this triangle right here. My marker is apparently not big enough. So let's, oh, don't do that. Let's go back one. Let's change the size of this real quick so we can shade it correctly. All right, so there is the region. The black is the region where all of my inequalities intersect. So that triangle is the region where all my inequalities intersect. And I can actually find the vertices of this polygon if I really wanted to. This would be a vertice right here. This would be a vertice right here. And this would be a vertice. So I would find this vertice by looking at where these lines intersect. So to find this vertice, let's call it A. I would use systems of equations to solve for the green line and the purple line. So I would say y equals x and y equals 0. I would solve, and I would find out that that is actually the point 0, 0, which makes sense. And then for point B, let's label that B, you would use the blue line and the green line. So you would use these two, and you would solve, and you would figure out what that point is. And then for point C, you would use the purple and the blue. So for this one and this one, that's C, and you would intersect those to find out where that intersects. Or you would use a system of equations to show and to find out where those two lines intersect. And that would give you your vertices. If you ever need to find the vertices, which sometimes you might. But what we're concerned about is graphing systems inequalities, finding out where the regions overlap, and then from there determining your region and showing the region where they all overlap. Now, why are systems of inequalities important? You know, when will you ever use them? Well, believe it or not, one of the most common uses for systems of inequalities are when you look at heart rates and like a BMI index, body mass index. You know, when you look at where does your heart rate need to be, between what area? It needs to be greater than this and less than this. That's two inequalities, and it kind of creates that little strip. So if you're looking at 80 to 90% of your heart rate, that's that red inequality right there. It has to be greater than, you know, if you're age 25, it has to be greater than 160, but less than 180 if you're looking at 80 to 90% of your maximum heart rate. So graphs like these, you might see in the doctor's office, or, you know, if you go to your physical, or if you're working out. These are the types of graphs where inequalities and systems of inequalities are used. The most common ones anyway.